Okay, this is a lesson on solving quadratic equations using the square root property with word problems. Actually, on most of these problems, we're going to use factoring, but there is one of the problems where I show you the new method of solving it with the square root property. So let's look at this first problem where I have I'm finding consecutive integers where the product of two consecutive odd integers is 63. Find the integers. So I'm going to start by defining let x equal the smaller of the two consecutive odd integers and remember that odd and even integers are separated by two numbers, so let x plus 2 equal the larger of the two consecutive odd integers. So it says the product of the two consecutive odd integers is 63, so this is x times x plus 2, that's the product of the two expressions, equals 63. Now we're not going to be able to use the square root method because we don't have a trinomial square on the left side, so we're just going to have to use good old factoring after I put things back together. That's x squared plus 2x equals 63. Then I'll subtract 63 from both sides, and I'll have x squared plus 2x minus 63 equals 0. So then I need to think of the factors of negative 63 that sum to 2, and that would be positive 9 and negative 7. So I factor it like so. And I use the zero products property. X plus 9 equals 0, or x minus 7 equals 0. And I subtract 9 from both sides. Here I'll add 7 from both sides. Now we really got to interpret our answers here because I have x equals negative 9 or x equals 7. So these two solutions actually sort of indirectly get our actual answer, which is going to be, there actually are two products, negative 9 and negative 7, that have a product of 63, and the other one is 9 and 7. Have a product of 63. So we don't want to give our answer as negative 9 and positive 7. We have two sets of answers here, and there they are, and the algebra led us to that, even though the math, the problem, we could have done this one in our head, but we're trying to practice an algebraic method here, so that's why we went to all that trouble. So let's look at this next problem. Let me try to get it a little bit bigger. So in this next problem I have a rectangular garden. So here's a rectangular garden. It's surrounded by this walkway, and the dimensions of the garden, including the walkway, are 24 by 16. So what would be the dimension of the garden if the area is 180 square feet? So what we need to realize here is that this 24, we get the area of a rectangle by base times height. Same thing with the garden, but this 24 includes this walkway on each side. The walkway is uniform, so we can assume that. So what you really have here is you have that width as x, this width as x, and then the same thing going the other direction. So if I say let x equal the width of the walkway in feet, and that would mean that the dimensions of the garden are, remember there's an x on each side that includes that 24, so let 24 minus 2x equal the width in feet of the garden itself. And then on the other side, you have, x here and x here, so you're going to subtract 2x again, this time from 16. So let 16 minus 2x equal the length in feet of the garden. And so that's going to mean my product is, so base times height, or length times width of the rectangle. So 24 minus 2x times 16 minus 2x, that equals 180. And so next we're going to FOIL these two binomials. So we'll go 24 times 16, and that is 384. And then we'll do 24 times negative 2x, negative 48x. We'll do negative 2x times 16, that's negative 32x. And then we'll do negative 2x times negative 2x, that's plus 4x squared equals 180. I'm going to combine these like terms and kind of put it in order. So 4x squared minus 80x plus 384 equals 180. So then I'm going to subtract 180 from each side, since that left side is not a trinomial square. And I'll get 4x squared minus 80x plus 204 equals 0. Let me just clean this up just a little bit right here. So I could spend some time trying to factor that, but remember, factor that with the lead coefficient of 4, but I'm just going to factor out of 4. That'll make things a lot easier. X squared minus 20x, and then plus 51 equals 0. I'm going to factor the trinomial here inside the parentheses, so that'll be 4 times x minus, that's 17 and 3 factors of positive 51 that sum to negative 20. That's negative 17 and negative 3. Now, zero products property. So zero products property would say, well, we do x minus 17 equals 0 or x minus 3 equals 0. And we can get one of the possible answers is 17, but that's going to be way too big. The math would never work with x equals 17 feet. So the width of the path is actually going to be x equals 3 feet. And then, so remember, we're subtracting, so 24 minus 2 times 3 would be 18 feet. That's the width of the path. And then the length of the path is 16 minus 2 times 3, so that's 10 feet. So the dimensions are 18 feet by 10 feet. Now back to some vertical motion problems. We have done problems just like this, and nothing new until we get to nothing new in the first part. So that's actually more of a review. So you have a rocket that's starting on the ground and it's going up in the air and then coming down. That's a vertical motion problem. It gets back down to the ground right here. So it's going up like so. And then it actually gets to the top and starts coming back down. Now, you use this formula right here. H equals H is the height at any given point in time. Again, we're actually starting out with H equals 0, and then H equals 0 when it gets back down here. And then it's at various heights on its way up and on its way down, and somewhere along the way it's at its peak. So this formula, this is your initial upward velocity is 144 t, so that's actually just your rate times time if it was at a constant rate, but it gets slowed down by gravity, and that's the gravity factor that slows it down but then speeds it up on the way back down. And that's what that is. So the first question is, how long does it take for the rocket to hit the ground? Remember, t is how long it's been since it was projected upwards in seconds. So what they're telling me when it gets back down to the ground is it's actually indirectly telling me that h equals 0. What we're looking for is t. All right, now we know it's going to be at h equals 0 at two different points. So one of the answers is going to be, that we should get, is that t equals 0 seconds when it takes off, and so that's going to actually be one of our two answers we're going to get that we'll exclude. So h equals 0, so I plug in 0 for h, and I have negative 16t squared plus 144t. And remember, to make this easy to factor, I'm going to factor out negative 16t, and that'll leave me with t minus 9. And so, again, this is this negative 16t equals 0, or t minus 9 equals 0. And this t minus 9 is what's going to count. This is going to get me a solution of 0 there. So, but when I add 9 to both sides, I get that t equals 9 seconds, and that's how long it took for it to go all the way up and all the way down. So this is the one that matters. T equals 9 seconds. So that's the first part. Now the second part, it asked me, find the height of the rocket in 3 seconds. Well, they're giving me t. I don't know what h is. And this one I'm not really going to use any algebra. I'm just going to say h equals negative 16 times 3 squared minus 144 times 3. And I end up getting, this all ends up equaling h equals 288 feet. So on the way up, I think it's you're going to see it's going to end up being on the way up, that it's at 3 seconds, after 3 seconds it's at 288 feet. Now, the next question I'm asked is, if the maximum height of the rocket occurs halfway through its flight, how high will it go? Well, let's remember that it took 9 seconds for the round trip. So half of 9 seconds, so it'll be at its peak at 4.5 seconds. So that's when it'll be at its peak. So we want to find out when t equals 4.5 seconds, what will be the height. So h equals negative 16 times 4.5 squared, and then plus 144 times 4.5, and we can just use our calculators to get that. And that gets us, when we do that, that's 324 feet. So that's when it's at its absolute peak. So that would be right here. It's at 324 feet. Now, the last problem with this problem set is, at what time or times will the rocket be at 320 feet? And this is important, the times. We know there's only one time when it's at its peak. That's at 324 feet. But so every other time it's going to be at a certain height twice. So that's going to be the case here. So we're going to get 2 answers. So remember, it's telling me what h is, 320 feet, and the time is question mark. So we have 320 equals negative 16t squared plus 144t. We're going to subtract 320 from both sides, and we'll get 0 equals negative 16t squared plus 144t minus 320. And we can't factor out a t this time, but we can factor out a negative 16. And I get t squared minus 9t, and then plus 20. So I'm going to factor this expression in here, which factors a 20 that's summed to negative 9. And so that would get me 0 equals negative 16, and then t minus 5 and t minus 4. So t minus 5 equals 0, or t minus 4 equals 0. So add 5, so t equals 5 seconds, and that's actually on the way down. It would be at 320 feet. On the way up, it would be after 4 seconds. So these are my two answers right here. T equals 4 seconds on the way up and 5 seconds on the way down. And let's slide this up. Last problem. Now this is the one we'll use the square root method with. And this is an object drop, so instead of going up and then down, this object is just going to be dropped. It's going to be dropped from a sky. It's going to be a penny dropped from a skyscraper 377 feet in the air. That's what S is here. S feet, and we want to know how many seconds that takes. So this simple formula captures it. So since we don't have a minus here because it's not being slowed by gravity, it's being sped up by gravity. So if S equals 1377, I'm going to substitute that in for the, let me start over there. So S equals 1377 feet. So 1377 equals 16t squared. I'm going to divide by 16 to get the t squared alone. And I get that t squared equals 1377 over 16. So I want to simplify that when I take the square root. So the square root of 1377 over 16. Well, 16 is a perfect square. And I'll tell you that noticing the divisibility rules, I have factor of 9 in 1377, and actually there's another factor of 9, so it has an 81 in it. So that's an 81 times 17 over the square root of 16. So this is 9 root 17 over 4 seconds. You could figure out what that is approximately, but that's the exact amount for the exact amount of time. Very, very roughly speaking, it's about, it's just a little over 9 seconds for it to drop that far. So that is the end of the lesson.